Alrighty, in this video we're going to cover what vectors are and how we use them specifically in the context of physics. And so we'll start off by actually writing down what the heck is a vector. So a vector is really just an arrow. Okay, that's really all it is. And a vector can represent many things. For example, it can represent the length of an object, maybe in this case 10 meters, or maybe it can represent the velocity of an object, how fast something is going, so 10 meters per second. It can represent the acceleration, so it can really represent anything you want it to, and this is what we call the magnitude. Okay, so I'm going to abbreviate that as MAG, magnitude. Okay, we also call just the number, so literally just the number, a scalar quantity. And so anytime you hear the word scalar, just know that they're just talking about the number itself and not really the direction. And so it's the direction, I guess what I'm trying to say here is that the direction is what makes a vector, right? So a direction added to a scalar quantity turns it into a vector. And so again, that direction can be denoted, really in this case, we can say right? So 10 meters per second to the right, or we can say positive, right? Because this is in the generally the positive direction, right, is usually positive. Or we can even say a compass direction, like east, right? So this is east. So again, any way that you choose to write the direction will work. The point is any vector will consist of a magnitude and a direction. Okay, so as we do more of these, you'll see different ways of actually writing directions. We can even use angles. But for right now, I want to discuss the three things we can actually do with a vector. And so let's go ahead and write those three things. And again, these are not the only three things you can do. You can do many more things, but these are just three things I want to talk about in this video. And it will be actually very useful for the lesson that we're about to do, which is kinematics. Okay, so the first thing we're going to do is we're going to actually add two vectors. Okay, and so when we add two vectors, we want to make sure that these two are going to be on the same axis. Okay, so same axes. Okay, and for the second thing, we're going to add two vectors again, but this time they're going to be on different axes. So maybe they can be perpendicular, maybe they don't have to be perpendicular, but for the sake of this case, we're going to make sure that they are perpendicular. And again, I'll explain what all of these mean in just a second. And the third thing we're going to do is we're going to actually take one vector and split it up into multiple. So split it up into two. Let's start with number one. Okay, so for number one, how do we add two vectors along the same axis? And so again, when I mean the same axis, I'm really referring to the coordinate system here. And I'm referring to either the x-axis here or the y-axis. Okay, and so again, if you have two vectors along the same axis, so let's just say we have one vector here and another vector here. Okay, these two are along the same axis. Maybe we have two along the y-axis that are pointing in the same direction. Okay, again, as long as they lay along the same axis, we can go ahead and add them together. And so let's go ahead and do an example. Let's actually draw a vector here. Let's call this vector, let's call this 5. And instead of putting, a compass direction like north, south, east, west, let's just go ahead and write this as -5, right? Because generally speaking, towards the left is going to be our negative x-axis, and so this is really a -5 vector. Okay, again, the direction already tells us that, but I'm just quantifying it as well. And then the next thing I'm going to do is I'm going to draw another vector. Let's call this one a little longer. Let's say this is a 6-unit vector. Okay, and of course that's going in the positive direction. And so again, I want to find the net or the total in this case. And so all I have to do is just literally add them like how I would add numbers. So in this case, I'm just going to do -5 plus 6. Okay, and so really, yeah, all we're doing is we're just adding vectors along the same axis, and it's quite as easy as just literally adding them together. And again, we can do that the same thing on the y-axis as well. Now, let's just do the same example, but this time what I want to do is I actually want to make them perpendicular. So when they lay on two different axes. So let's just make this -5. Let's keep this right here. And instead, let's take this 6 and let's actually move it down like that. Okay. So what I want to do is I'm actually going to move this like that. Okay, so now this is going to be -6 because again, this is pointing down, and usually down is negative. And now I'm going to try to add them together again. But this time, notice that we can't somehow just like add them together. okay, we have to actually use the Pythagorean theorem. Now, before I do that, I do want to point out one small thing. And, in this case, a lot of students, they typically just sort of connect these two like that, and they kind of call it a day, and then they apply the Pythagorean theorem. However, the proper way to do this would be to actually take one of these vectors, okay, it doesn't matter which one, just take one, and actually move it such that they're in the orientation of tip to tail. And so what do I mean by that? Well, as you can see here, I've moved the vector such that the tip of this vector is at the tail of this vector. Again, it doesn't matter which one you move as long as they're in that position, okay? Then what you want to do is go ahead and connect them. And so I'm going to go ahead and start from the tail, and I'm actually going to connect them just like that, okay? And that green line right there is what we call our resultant vector, okay? And I'm going to put the resultant like that. Okay. And again, the reason I'm putting them in absolute value signs is because I'm letting the reader know, or whoever's looking at this, know that I'm just going to be finding the magnitude. Okay. Even though this is a vector, I'm just finding the magnitude or the length of this vector. And so again, how do I find that? I use the Pythagorean theorem. And so this is, of course, the hypotenuse. And so we can say this is r squared is equal to -5 squared plus -6 squared. All right, and so once you simplify that, you're going to get an answer of about 7.81. Okay, and again, this is supposed to be a vector. However, I'm just looking for the magnitude, and so if I really want to make this the correct answer, I really should write it like this, right? And so this is telling me the magnitude of vector r is 7.81. But what if I actually want to find the actual vector? Then how would I do that? Well, it's pretty simple. I'm going to write the same thing again, but this time I'm going to state the direction. Okay, so I'm just going to add a direction. So if you notice, this is sort of pointing. We can use compass directions in this case, and we can say that looks to be about southwest to me. And so again, this is south, and this is west, and so this is going to be southwest, this vector. Now that's an approximate direction. If we want to find an exact direction, then what we have to do is we have to find an angle. Okay, so then we can say, hey, it's exactly this many degrees south of west. Okay, so how do we do that? Well, it's actually pretty easy. We can use a bit of trigonometry. And so what I'm going to do is I'm going to realize that I have two parts of this right triangle. I have if I'm trying to find this angle, and let's go ahead and mark that angle actually. So let's say I'm trying to find this angle right here, and I'm going to mark that as theta. We usually call angles as theta. And in order for me to find that, I'm going to realize that I have the adjacent side to that angle, and I also have the opposite side, and that's -6. And I can actually write that -6 out here just to make it more clear. And so again, I have the opposite side and I have the adjacent side, and that should ring a bell. It should remind you of SOHCAHTOA, specifically TOA. Again, TOA stands for tangent, so tangent is equal to opposite over adjacent. And I should even put tan theta here. Okay, and so again, just filling it in, so tan of theta is equal to the opposite side. So in this case, the opposite side is -6. So I'm going to put -6. And the adjacent side, adjacent means next to, and so the side that's next to the angle is -5. And we can go ahead and simplify that and solve for theta. And so I'm going to take the inverse tan on both sides, and I'm going to be left with theta is equal to the inverse tangent of 6/5. So that will give you a result of about 50.2 degrees. Okay, so now we can actually use that degree and state the precise direction in our final answer here. And so just kind of going back to the final answer, I'm going to write it right here. It's going to be 7.81, 50.2 degrees southwest. Okay, so just to quickly recap, we have successfully added two vectors along the same axis, whether it's the y-axis or the x-axis. And we've also added two vectors that are perpendicular to each other. So one on the y-axis and one on the x-axis. The important thing to remember here is that when you are writing your final answer, make sure that the final answer is in fact a vector quantity, because again, it's an arrow. And an arrow, a vector, has a magnitude, and it also has a direction. So one, you actually have to find the length of it, which we call the magnitude, or the scalar quantity of the vector. And the second thing is to actually find the angle. And so in this case, we used the tangent function to find the angle, but you can really use any trig function to find the angle. Okay, lastly, we're gonna actually cover how to do this. We're gonna take one vector and make it two. All right, so I'm gonna go ahead and draw a vector in a random direction. Okay, and I'm gonna call this, let's call this vector A. Okay, and I'm gonna give it a magnitude of about, let's give this a velocity of 10 meters per second. And let's say that this vector is going to be at an angle of, I don't know, let's call that 45. Looks to be about 45 degrees above the horizontal. So again, this is the horizontal, and this vector happens to be approximately 45 degrees above that. So our goal here is to basically do the opposite of what we did the last time. So the last time we combined two vectors, now we're going to take that one vector, this is the hypotenuse of that triangle, and basically break it down into two other vectors, okay? And so let me go ahead and actually visually draw it out, and then maybe you'll start to understand here. So this is going to be the x component of the vector, and here's the y component of the vector. Okay, so as you can see, all I'm really drawing is a triangle. I'm just making it into a triangle, and that's going to be a right triangle, of course. And the original vector that I was given, this black vector, is going to be the hypotenuse of that triangle. Now, in order to find this side and this side, we just have to use a little bit of trig. And so, again, if you are not too familiar with trigonometry, again, it's not too difficult. We're not diving too deep into the trig here. We're really just using SOHCAHTOA. So I'm going to write that out here. SOHCAHTOA, and that's really just a simple way of using the sine, cosine, and tangent functions. And so in this case, what we can do here is, if we want to find, let's label this the x side and the y side here. In this case, if we want to find the x side, we have to realize that we are given the angle that is adjacent or next to the x side, and so this x side is going to be my adjacent. And I'm also given my hypotenuse. So I have the adjacent side, and I have the hypotenuse, so A and H. And so which one correlates to that? That's my cosine, right? A and H, cosine. And so what I can do here is I can start solving for x here. I can say cosine of theta is equal to adjacent over hypotenuse. Again, that's what cos stands for. Cosine is equal to adjacent over hypotenuse. And now I can just fill it in. So I can say cosine of theta. Again, theta is your degree, so it's 45 degrees. And that's going to be equal to the adjacent side. In this case, again, the side that's adjacent to the angle is x. And the hypotenuse in this case is going to be 10. All right, and now all I have to do is solve for x. So in this case, I can just simply multiply by 10 on both sides. So x is going to be equal to 10 cosine of 45. Let's go ahead and actually do the y side as well now. This is the opposite side to the angle. So again, the angle is here. This side is opposite to that. And we're also given the hypotenuse. Okay. And so opposite hypotenuse, that should match up with so. And so let's go ahead and actually do that. So we're gonna write here so. Actually we can just write sine. So sine of theta is equal to opposite over hypotenuse. Now we can just fill it in. So sine of 45 is equal to the opposite side, which is again the y side, over the hypotenuse, which is 10. And I simply go ahead and solve for y. So y is equal to 10 sine of 45. Alrighty, so I went ahead and plugged them in the calculator, and I got a final answer of 7.1 for the x side. So I'm going to write that here, 7.1, and I've also got a value of 7.1 on the y side. And again, just to clarify here, that these are simply just the magnitudes. If I want to make this into a true vector, which is what this actually is, I would need to add a direction. And so in this case, I can simply just put, for this case, I can put east, and I can put north here. Okay, and so we're done. That's all it is. So we've officially taken one vector and split it up into two. Now you might be wondering, why on earth would I ever need to do this? Well, in just a few short lessons, we're going to cover how to actually apply this to projectile motions, which is kind of like kicking a soccer ball from the ground at a speed of this much, at an angle of this, and figure out exactly how fast it's going to the right in this case, and also how fast it's traveling upwards, because anything that's a projectile is really moving in two dimensions. So again, I'm gonna leave that for a different lesson. In this lesson, I just wanted to cover how to sort of break one vector apart into two, how to take two vectors and make it into one, and also how to add two vectors along the same axis, whether it's the x-axis or the y-axis. Now, I do want to clarify that it is totally possible to add two or even more vectors. So there are some questions that are going to involve the adding of three vectors or four or five vectors. All right, I'll see you in the next lesson.